Dear students, today we are going to discuss about a structural tool that is Stud Pro. In that we are going to take a problem and we are going to try to validate that problem. Okay, so we can see this is basically a beam. This is a span of 8 meter having two supports. One is pinned support and one is roller support. And UDL is basically applied on that. That is uniform distributed load. That is of minus 5 kilonewton, which is in minus y direction. Now here basically these are the properties of material. The first one is going to be for that concrete grade, that is M30. After that these are that longitudinal bars and your horizontal bars. Okay, so these are going to be that reinforcement bar. That Stud Pro automatically is going to take that bar dia when we are going to design it. So beam section is going to be 300 mm into 300 mm, that is 0.3 meter into 0.3 meter. And obviously I told you in that figure when I was explaining it, that was uniform load, that was minus 5 kilonewton per meter. So that load type is going to be the dead load. Okay, and after that we are going to validate it with this formulas. Okay, we are going to mathematically calculate that, and these are that basically mathematically calculated values. After that you can see the bending moment is 40 kilonewton and the shear force, the reactions on the joints are going to be 20 kilonewton. Okay, so let's move to that software now. So this is your Stud Pro Connect, the latest version. So here you can just go with that new, and after that the units are very important. So you can basically set these units from that configure when you start or you install this tool. So here you have to go for that metric, otherwise in English it's going to be foot and inches. So right now already I have done that, so I'll just you can give your problem description over here, just like structural analysis of beam design using FEM technique, and this is that location you can save your product. Okay, your component. So we will directly go for that create. This is basically the interface of Stud Pro. So directly I'll go with that problem. So just go for that grid. There are basically near about 5 to 6 way of making geometries. So right now we will take BIM grid, and here you can add it this grid. Okay, this is basically 0 to 10 meter and 0 to 10 meter on that y direction. Okay, so here there is an option on that editing toolbar of snap node beam. You have to edit it. You can add it basically the grid. So here you can see this is basically your default grid, that plane xy plane you want to select, or xz. Okay, that is basically the top view we are going to start with, and that component is basically in isometric view right now. So if you want to change the origin, that is your original origin is like x0, y0 and z0 over here. So we are not going to change that. Sometime if you want to give a geometrical dimension over here on the y direction or z direction, you can give it from here. Now the basic thing which we have to do is that over here it is still the 10 meter spacing it is showing, and here it is basically the spacing, that is 1 meter. Okay, each is going to be your 1 meter. So right now we need only one grid, that is you have already seen in that geometry. Okay, this is basically of 8 meter span. So what we are going to do is we are just going to give in x direction 8 meter span. So we have only one grid, and after that obviously it is 8 meter span. Just write 8 meter over here, and in y direction we are going to have nothing, so we are going to keep it like 0. So via that editing grid also you can basically make your geometry, because it's a simple beam which basically is not too much critical geometry. So we can do it by editing the grid also. Just do it. Okay, now it's only a reference line, that is a construction line. So what we can do is just snap and node beam is going to help in that case. So what we are going to do, we are just going to start it from clicking from here and just click on that another one. So 1D beam is being created. Okay, so now the second part you can basically clear off that. You will able to see this 8 meter beam. If you want to validate the geometry, even that you can do. So in utility we have to go for that beam tool. You can give the dimension for that beam and you can display. Okay, it's a 8 meter beam. Okay, so if I don't want it, you just do it remove and close it. After that what we have to do, go back to the geometry Now we have the next step in FEM, that is we need to assign the cross section, which is 0.3 meter into 0.3 meter. Okay, that is a rectangular cross section we are going to assign to this beam. Just click on this properties. After that, for defining the cross section, just define, click on define, click on rectangle. We are going to write 0.3 meter. You can click on tab, 0.3 meter. Okay, and after that you need to, this is your material. Basically you can get this various materials from here. So right now the material for my beam is concrete, and the material grade is M30. Okay, right now we are only assigning concrete. Just add it and close it. So it's basically the cross section. Need to assign to this geometry now. So overall in that complete window we have only this beam, so we can use these assign to you view. So here there are another options also. Okay, you can assign with the help of cursor, or directly you can assign to the selected beam. So just I'll go with that assign to view, assign, and just assign. You will see here that R1, you can see this is your reference number 1, and this is your rectangular property, that is 0.3 into 0.3 meter. Okay, so that has been assigned. So that's why it is showing here R1. Now the second thing is the grade. So you can come on that material. After that, just click on that concrete and add it. So my material grade is M30. So I'm just going to type M30, that is 30,000 when we are going to convert it into kilonewton meter square. Okay. Sorry. So just do it. Okay, and need to assign it. So you can assign to view. Okay, that similar way. Right now you can see that concrete grade has been assigned over here. Now need to assign the supports. So just create that support. So we have a pinned support over here, add it. Now again we will go for that roller support. So you can see basically we have enforcement butt over here, and your fixed butt. So in this basically that release options are available. So you can release those coordinates. We have our movements in all the directions. So right now I'll do it in that X direction, and you can click on these two where that movements are not going to happen. Okay, so after clicking it, just add it. So we have these two supports. Now when you want to see which one support, basically both looks like similar one. So this is basically your pinned support, and this is your symbol of roller support. So we are going to just use cursor to assign. Just click on that assign and just click on the nodes. Okay, now I want to assign the roller support. So just click on that roller support and click on assigning. Now we need to define the load. Okay, we know our load is basically dead load. Okay, and that is -5 kilonewton UDL on this complete beam. Okay, so just add that. Need to define the dead load. This is just we are doing the naming of the load. Under it we are going to define. Okay, and even there are combinations. Okay, for your safety of factors and those critical buildings or residential buildings, you can define the combination. Right now only we have the dead load, so we don't need to do that. We need to just click on that dead load. After that, just add. After adding this, basically you can add the self weight of the beam. Obviously we know that self weight is the weight of the building, which is always -1. So what we need to assign, we need to go in member, and there is a uniform force. Okay, that is UDL. So we need to assign that, that is -5 in global y direction. Okay, so you can see here we have already checked out that global y direction, and just add it and close it. You can see it is not yet assigned, the question mark is there. So we are going to click on this. After that, what we are going to do, we are going to use cursor to assign, and click on this and just click on this line. Okay, this beam. So you can check out that. Now if you want to validate the beam, that loading, so you can right click and you can go for that labels. After that you can go here and click on that label load values. So just apply and just do it. Okay, you can see here the -5 kilonewton has been assigned, that is UDL. So normally that dead load simply we have assigned, and supports we have assigned. Almost if you check in the problem, all the things we have done. Okay, all the things we have done. Now we need to validate our results. Okay, so how basically we are going to analyze our problem. See, analysis is basically a simple analysis to just validate that problem, but design is according to the Indian standards. Okay, so if you want to learn this software and you want to work with validations and you want to talk about that Indian standards, either we are talking about earthquake design or wind analysis or footing design or a lot of other things which are very important for civil engineering. So today just we are going to validate, we are just going to analyze, and someday else we are going to talk about design. Okay, so it's very important. There is difference between analysis and design. Design is something which is going to tell you how much reinforcement that component is going to take. You can even do that quantity takeoff of beam, column, slab. Okay, so just we will go in analysis, just click on that define, and here nothing you need to do, just add whatever you have done. Okay, the things are going to come here. Okay, you can see that constants, supports, loading, whatever you have done has been added to the command window. So after that close it, and you can see here there is an option of run analysis. Okay, you need to click on this. After that you just say yes, we want to save, and you can see here the most important thing when we have run this analysis, no, there is basically first one, that is errors, warnings and notes. Okay, so you need to understand this. This is going to help you when you are designing any of the components. If there is any error, so your design is failed. If you are working like warnings are there, so warnings can be like we have assigned some loads, we have assigned some supports, we have given some properties. In future it can create some problem which that constraints we have given, so it can be a little bit of issue in that. So there is not going to be too much problem when warnings are going to come, you can ignore them. Nodes are basically that future nodes, anything that software wants to tell you that it can play. And below here you can see we can have an output file. It will help us when we are going to design. Okay, right now for analysis I will not go for that directly. Today what we are going to do, we are going to go for that go to the post process, and we are going to validate our problem, that bending moment and shear force, which basically after mathematical calculations and after the simulations we have done are same or not. Okay, so go for that, go to that post process and you done. Now obviously it is going to show you whatever that load you want to see, selected one, and after that just apply and do it. Okay, now this is your result window. Okay, everything has changed now. On that result window you will able to see the results. So right now I can see the displacement. Okay, you can press shift and FN and you can check the deformations, and you can enlarge the scale also. So here my reactions are going to be my first thing. So in reaction you can see that is basically 20, that is your shear force. So if we are going to check here, our shear force is 20. Okay, that is validated. So after that, that beam results. Okay, so in beam results, what we need to do to see the beam results, over here you can just double click on this. When you are going to double click on this, you can see in this beam window your shear and bending results are there. Okay, can you see here that minus 40? Okay, so minus 40 is your bending moment. Okay, that UDL we applied, so here basically that 40 is going to be there. So in this case you can check that bending moment is 40, so our bending moment is also validated. So after that you can close it. Only that beam was there if you have designed some plates, solids, and even you can create a report. You can click on that report. So input already we have given, you can write on that output. Need to check out any of these things, just like node displacement or anything, beam summary, you can just bring them this side. Job information you need to bring that side. So just do it. Okay, you will see a report is going to be there. Whatever that work you have done, that complete beam displacement details is going to be there in your X, Y and Z directions. Okay, and that results are going to be shown over there. So fine. So if you have any queries, or if you want to have these trainings with validations on that building designs, on earthquake designs, or that advanced structural analysis part for RCC and steel, even we talk about the theoretical part, so that you can understand the software in a very well manner. So I'll say, if somebody is having any queries or questions, please put in your link. Okay, thank you.